Okay, so how do you find the area under the curve, or the probability, given the z-score? And we're going to be using this table, which is called the table A2, and you're going to be using the positive z-scores and the negative z-scores. Now, there's the negative z-scores and there's the positive z-scores. Now, one thing I would like to focus on, and I have to find my handy dandy remote control, and I'm still looking for it, and I'm still looking for it, and I still don't see it, so I'll have to use the manual. So let's see, focus, zoom, there we go. I'm going to zoom really up tight, and notice what it says right here. Standard normal distribution, cumulative area from the what? From the left. I'm going to take my handy dandy highlighter and I'm going to highlight this, which that means you should be doing it also. That means that it's giving you the area from the left. So that's that area right here. And the z-scores that are negative are to the left of this 0 right here. Okay? Now the right side, positive z-scores from the left. That means that these scores will be on the right side of the 0, and it will be the area to the left of that z-score. Here's our z-scores across the top and down the side. Let me zoom out a little bit. And here's our z-scores across the top and down the side. Everything else is 4 digits, which means probability in the body. So we'll be using those two tables to get our answers in these examples. So let's start off with one example. This example is in the book. Example 1, I believe, or example 3, I can't. It says a randomly selected adult undergoes a bone density test. Find the probability that the result is reading less than 1.27. So they want to know bone density, want to know if it's less than 1.27. Bone density reading less than 1.27. Now, I'm going to tell you what I tell my class when I'm teaching a regular class, traditional class versus online class. Draw a picture. There are many students that have less degrees than I do, and they don't think they need to draw a picture. I draw a picture, and I have several degrees. So if I have several degrees and I draw a picture, then probably you need to draw a picture also, no matter how smart you think you are. So what we need to do is draw a picture. And 0 in the middle. 6.2, the mean is going to be 0. Make that note. 6.2 material, 0 is equal to the mean, and the standard deviation is equal to 1. So that means a z-score of 1 to the right and 2 to the right, -1 to the left, -2 to the left. So there, all your 6.2 problems are going to be set up like this normal distribution. Now, we'll take another color, and we'll color orange, and we're going to mark our spot that we're being asked about. 1.27. Now that is a positive z-score. Now if it's a positive z-score, naturally it's going to be on the right side. So you plot it just like you would on a number line. 1.27, well this is 1.5. 1.25 would be half of that, so we'll just put it right here. I'll draw a line right here, and I'll put a little arrow that says z-score is equal to 1.27, and then I will shade this area because it says less than, that means to the left of 1.27. So I'm wanting to find this area under the curve. So I'm looking for 4 digits, 4 decimal places, because I'm being asked for an area or a probability. So I go to my handy dandy table. I know it's on the right side, so I will go to my handy dandy table. Oh, that's negative z-scores. Don't use that. Go to positive z-score, and I'm gonna have to blow this up a little bit. Need to find my dadgum. There it is. Remote, dang old remote control. Okay, and zoom in. Now you're going to have to work with me here because I can't get everything on the picture and you can see it. So first thing I'm going to do is find 1.2. So I go to my left hand side, and there is 1.2 right here. There's 1.2. Now how do you get $1.27? Well, you take $1.20, that's over here, and you add 7 cents. So I'm going to have to go out a little bit so you can see it. And I take my handy dandy straight edge. Can't find it either. And I'm going to draw a highlight of 1.2 all the way across. And you don't have to do this every time. I'm just doing this to show you how to use the table. So there's my 1.2 all the way across. And then my 0.7 is right here. So my area under 1.27 is right there. And we'll zoom in right there so you can see it. And that area is 0.8980. It's 4 decimal places. So that is 0.8980. So what is the probability of having a bone density score of less than 1.27? Well, your probability is 0.89 or 0.90. The probability of your bone density score, I don't know what that bone density score, being less than or equal to 1.27 is 0.8980 or 0.9. Now, I'm going to go ahead and put in here the complement. Let's go ahead and refresh our memory on the complement. What is the complement? The complement is the other half that makes the whole. Our whole is 1.000. So if my probability of being less than 1.27 is 0.9, then what is my probability of being greater than 1.27? I'll take my yellow highlighter and I'll say, what is this probability right here of being greater? Well, the probability of being greater, bone density score, being greater than 1.27 is going to be equal to 1 minus 0.9, which is 0.10 or 0.1. Okay, so that's the complement. Now, be very sure you understand what the complement is. The complement of 0.9 is 0.1. If this was 0.7, that would be 0.3. If this was 0.65, this would be 0.35. Okay, whatever makes up the whole. and the whole is 1.000. We talked about that in the introduction. Now, there is another way you can find this area. The other way is using technology. I don't have a calculator with me, but you can go to normal, let's see if I can pull it up on my computer here, the TI, and I'll just tell you what the operation is. You can go to your TI and you can pull up math, and under probability, I'm trying to find it. I don't know why I can't find it. Okay, I've done past it. There it is. It's on page, I don't know what page, 248. And go to second vars, and I'll show you where second vars is on your calculator, on your TI. This is a TI-83. There's your screen. Second function is right up in here. It's usually a yellow button. Let me look on my on-screen TI and see what color it is. Well, where's my calculator? There it is. It's kind of a yellow button, and then vars is right beside your clear button. Your clear button is right here, and your vars, which means variables, vars varies, second vars. So hit second vars, and then go down till you see normal CDF. I don't know what number it is. Maybe number 2, normal CDF. Normal distribution, CDF. Now, when you type in normal second vars, normal CDF, what they're asking you for is the z-scores that you reading from left to right. Z-scores from left to right. So in this case, you're coming from the left-hand side. Let's go back to our example. Here's the left-hand side. Now, some of y'all may remember back in elementary school, junior high, whatever, what's this arrowhead called over here? Negative infinity. And what's this arrowhead called over here? Positive infinity. Now, if we're reading from left to right, our area that we want is the orange area. So that's from negative infinity to 1.27. Well, how do you type in negative infinity, Hubert? Just type in 999, 999,000, 999, 999,000,999. It doesn't matter. Just, I would suggest more than 3 digits. So what I tell students to do is type in 999 for infinity. So negative 999 to 1.27. And type that in. It'll be asking you for, it'll have parentheses and bracket, I think. I don't know what it has when you type it in. Let me see when you type it in. I get second vars, and normal CDF is 2, and I would type, it's got a parenthesis there, I would type in negative 999. Don't use the subtraction symbol. Use the negative, which is beside your enter key down here. Here's enter. Use your negative right there. Negative 999, comma is right above the 7, and 1.27, and then close parenthesis. And hit enter, and you should get 0.8979. And let's see, we get 0.8979. And what was our, by hand, it was 0.8989 8.80 versus 8.8980. So you see there's not much of a difference between the two areas. And that's how you find it on your TI 83 or above. Now, what if you want to do it on the spreadsheet, Excel spreadsheet? Well, you can do the Excel spreadsheet also, but you will have to type in the cell norm dist, and then in parentheses. So let me show you that. In the cell, you would type in norm dist, and then it'll ask you parentheses. You'll type in negative 999 comma 1.27, and then after you do that, hit enter, and then the cell will have 0.8970 or whatever it came out to be. So you can do it in Excel spreadsheet also. Okay? Now, that's usually not the problem students have with these problems. What they have is reading the question and what to do after you read the question. And some of you may be saying, well, Hubert, what does that mean? Well, sometimes they will throw in a little bit of a monkey wrench into the question, and the student's head will explode because they're trying to figure out what is it asking. Like for instance, they say, find a bone density. What is the probability of finding a bone density above -1? What is the probability of finding a bone density score above 1 or -1? All right, they want to know what is the probability of finding a -1 or more score, bone density score. So you draw a picture, and I tell students in my class, get you a blank sheet of paper, put about 6 of these on, make 6 small normal distribution, 1, 2, 3, 4, 5, 6, and then run you 15 copies, and you won't ever have to draw this over and over and over again. I tell a lot of my students that. We'll go ahead and label it, and you can do the label. You can label these for 6.2, which is 0, 1, 2, 0, -1, 2, and then leave it blank for 6.3, because 6.3 you're going to have different numbers down here. So where is -1, Hubert? Well, -1 is right here. Well, that's simple. Yes, but the catch is they're asking you greater. Well, wait a minute, Hubert. You said that the graph gives us, or the handy-dandy table gives us to the left. Yes, and I also told you that if you ever want to find the right, it's the complement. All right, so let's write that down. If you want to find less than is pretty much what you get out of the table. Okay, so if it says less than 1, you look up 1 and you find out what's in the table, -1, and you look up what's in the table, and whatever's there is this area right here. So when you see the words less than or up to -1, that means everything to the left, and the table will give you that answer. But if you want to find the right hand side, which means more than or greater than, when you see those words, you got to do the complement. And I don't even tell, I tell students it's the complement, but I also tell them 1 minus the left hand side. Okay? And that's how you find anything that has more than, greater than, at least. At least -1 means, anytime you see at least -1, that means anything greater than -1. So when you see these words right here, that means you're going to have to take 1 minus the right hand side. So let's do it, Hubert. Well, we want these numbers right here. I mean this area right here. So I'll put that in green. That one's going to the trash can because it's dry. Now, if we don't know what that is, we're trying to find it. So what do we do here? Well, we find -1 in our handy dandy negative z-score. Negative because it's a negative number. So -1. Okay, I'm going to blow it up so you can see it. Dang old technology. Alright, -1. Up, there's -1 right there, Hubert. Right there. -1 point, well, Hubert, what is 1.0? Well, it's 1.0 plus 0. There's 0 up here, so there is our area, 0.1587. That is this area right here. .1587. Oops, sorry. I'm gonna quit zooming in and out because it messes the camera up. Alright, so this area is 0.1587. Well, that's not what we want. We want this side. So we go down here, 1 minus 0.1587, and that's going to give us, and use your handy dandy math, let's see, 3, 8, 9 be 0, 3 and 8.8303. I have no idea. So you have to check that. Let's check with our handy dandy calculator. Our handy dandy calculator will go from the second bars, normal CDF, and then go from -1 to, what arrow are we going to? Oh, that'd be 999, positive. Yep. So that'd be comma 999 and closed, and that's 0.8413. 0.8413. Okay, so 0.8413 is your area. So the probability of a number being greater than -1 is 0.84, or 84% chance. 0.84 probability, or 84% chance. And that's how you find that one. So the first type of problem we did was a straightforward, what is the area to the left? The second problem we did is the area to the right. And what's the other problem that they're going to give us, Hubert? Well, the other problem they're going to give us is the problem that says between. And I'm just going to make one up. And I'm going to say they want the area between, let's go with 0.6 and -0.2. -0.2. I don't have any.
We don't have any? Okay, because I'm tying it up.
Okay, thanks.
Okay.
All right, -0.2 and 0.6. So they want this area right in here. Well, let me use another color. Let me use this blue. This is the area they're wanting. Now, how do we get that area? Well, you take the larger area, which is the yellow, and I'm going to draw it right here. You take the larger area There's the larger area. It's in yellow. And you subtract the smaller area, which is in orange. And if you take these two pieces right here and you lay them on top of each other, the area that you have left is this area right here. And that's the area we're wanting. And if you, let me give you another scenario, and we'll come back to this. And I give my students this when I'm teaching them in class. Let's say you live in Anderson, and you know if you head north, you go to Greenville, and if you head north further, you go to Spartanburg. All right? You live in Anderson. I'll put live right here. And let's say that you decide you want to go on a trip to Spartanburg. Now, of course, whenever you say something about going somewhere in a group of people, there's always one person that says they can go there in 10 seconds, where everybody else takes 8 hours. So I don't know why a lot of cavemen do that. But anyway, we're gonna say that we're driving normal, normal like 65 on 85. That's what you're supposed to do. Oh, I drive 110 on my. Oh, shut up. All right, we're not talking to you. We're talking normal people that drive the speed limit. All right. A to S. If it is, let's say, 75 miles, and I'm just using that. I don't know. I don't need anybody saying, "Whoa, what part of Spartanburg are you going to?" Shut up. I'm just using numbers, okay? 75 miles. It is 75 miles from Anderson to Spartanburg. And I tell you, it's 35 miles from Anderson to Greenville. How you going to find what's between Greenville and Spartanburg? Well, everybody knows you're going to subtract. Well, that's what you're doing with the problems in the middle. The problems in the middle, you have the larger area and you subtract the smaller area. And that will give you the area in between. So in this case, that'd be 75 miles minus 35 miles, and that's equal 40 miles. Okay, so you took your greater distance and you subtracted your smaller distance, and that gave you what was left. Same thing here. You take your larger area, which is the z-score of 0.6, and you subtract your lower area of -2, and that will give you your middle. So let's go to our handy dandy, and I'm not going to blow this up. All right, 0.6, if you follow your handy dandy table, 0.6 is right here. I'm going to drew through it. 0.6 is 0.7257. -0.2 is 0.0007. So to find the area right here, we subtract the 2. And the 7 will cancel, and that will leave 0.725. And that is this area right here. Now let's check it with the handy dandy calculator. And what's our left hand side? 0.2. So you would type in second bars, normal CDF, -0.2, comma, 0.6. and close parentheses and enter. And you get 0.3050. Well, we've done something wrong. 0.3050. I bet I looked up the wrong thing on the table. Let me look up right quick. Negative 0.2. Oh, I know what I did. I looked at the top right here. That's 3.2. Sorry. Negative 0.2 is 0.4207. 0.4207. Sorry about that. 0.4207. And the 7 will cancel. 5 minus 0 is 5. 12 or 2 minus 2 is 0. And 7 minus 4 is 3. And they're both equal. Okay? So, you've got 3 types of problems with the z-scores. And this is 6.2 as well as 6.3. 1. You've got a problem that's going to say less than or at most. Anything like that, that means you're going to read the left-hand side area. And the left-hand side area is what the table gives us. Okay, so that's the first type of problem you're going to have. The second type problem you're going to have is when it says more than. Or it's going to say at least. Or greater than. If you have any of these, then you know you're going to use the complement. Or you're trying to find the right-hand side. And the right-hand side is equal to 1 minus the left-hand side. And this is basically what we call the complement. So remember that. And the third is you're finding between. And when you look for between, you're basically going to take your larger area minus the smaller area. And that's going to be equal to in between. Now, with your handy-dandy calculator, all you have to remember is left to right. So using these 3 with your handy-dandy calculator, you type in second vars, negative 999, comma, and whatever number, second vars normal CDF, and that will give you your area on the left-hand side. Okay? If you type in normal CDF and you start with our example that we started with a while back, we did negative 1 to 999, negative 1 to positive 999, and that will give you the right hand side area. And I think in our first one, let's see, I think this one was 1.27, and I think that came out to 0.8980. And this one was 1 point greater than 1 or negative 1. That came out to be 0.8413. So you can check yourself on your calculator, rehashing this. Go ahead and check your calculator to make sure you can pull up these problems. And the third one, normal CDF. And I think we went from, looking through our problems here, negative 0.2 to 0.6, and that gave us between of 0.3050. Now remember, second vars. Second, which is the yellow key, and then vars, V-A-R-S, which is beside the clear key. And type in these values, and you should get these three areas. Okay? Now, I'm going to go ahead and talk about 6.3. And the reason I'm going to go ahead and talk about it is because it's not much more difficult than 6.2. The only problem is you have to remember to change your z-scores. 6.3, they give you a z-score modifier formula, as I tell my students. It's basically to convert. And it's a real simple formula. It's x minus x bar over the standard deviation, or x minus mean over the standard deviation. And that's equal to the z-score. We've done it before. We did it at the end of Unit 1, and you shouldn't have a problem doing it. X minus x bar over standard deviation. So 6.3, the only difference with 6.3 from 6.2 is you have to convert to a z-score first. And you're going to use z is equal to x minus x bar over standard deviation. Now we're going to do a quick example, and you'll see how you can you'll see the similarities between the two sections. Let me pull up an example. It says the social organization Tall Clubs International has a requirement that women must be at least 70 inches tall. 70 inches tall to be in their club. At least. Okay? That's the requirement to be in the tall club. Alright? Given that the women have normally distributed heights with a mean of 63.8 inches, 63.8 inches, that's the mean, and a standard deviation of 2.6, or S is equal to 2.6 inches. Okay, that's normal, that's just women, not women in the club, that's just women. So this is women in general. Women in general. To be in the tall club, you have to be at least 70 inches tall. So they want to know, what is the probability? Well, that's simple. You just draw your handy dandy curve. Your mean is 63.8, and we'll add 2.6. 2.6 is going to be 66.4. Y'all check me. And 69 inches, and going back this way is going to be 61.2, and going back this way be 58.6. I don't know, something like that. 58.6. I don't know. Okay, so you want to know 70 inches tall. So we take our handy dandy red marker. 70 inches. 70 inches is out here. So we want to know at least. That means they have to be taller. So we need this area right out here. That's what we need. That's what we want. Right there. What is the probability of one of these women being in this club? 70 inches. So you just look it up on your z-score. So you go over to your handy dandy z-score and you say, okay, 70. Oh, wait a minute. 70, that'd be positive. So you go over to 70. So, our z-scores don't go up to 70. No, z-scores don't go up to 70. They go up to 3. So you quit the problem and quit school. No, you do not. You change your given numbers to z-scores. So you draw a handy dandy table down here. A handy dandy, and you're going to say 0, 1, 2, and 1, 2. And you're going to change this guy to a z-score. How you do that here? Well, you follow this right here. So that's going to be 70, and that one's gone. 70 minus 63.8 over 2.6. And you take your handy dandy calculator and crank that out. 70 minus 63.8 and divide that by 2.6, and that gives us 2.38. So R70 translates to a z-score of 2.38, and that's the difference between 6.2 and 6.3. Now you go to your handy dandy calculator, or you go to your handy dandy 2.38. Well, let's find 2.3. 2.3 is right here, 8 is right here, and I get a score of 0.9913, and that is to the left hand side. 0.9913. So we need the right hand side. You take your handy dandy calculator and you say 1 minus 0.9913, and that gives us 0.0087. So this area in red is 0.0087, which is 0.01, which is 1%. So how many women are going to be able to join this club, given this statistic? 70 or 1%. So for every 10 women that you have, 1 is going to be able to go into the tall women's club. And that is the difference. The difference here is you have to convert to a z-score given this information. Now, what you want is going to be x. That's what the question is asking. What you want is x. X bar is going to be given, and s is going to be given. Sometimes this may be called mu, and this may be called omega, or sigma. I'm sorry, sigma. And this will be called probably x. Yeah, it'll be always x. Now, one other thing in 6.3 they may do, and 6.2. 6.2 and 6.3, they may give you the area and you find the z-score. And that just goes backwards. They may say, okay, you are doing something in a company and you want to know the probability of, or you want to know what reading. This is 0, this is 6.2, -1, -2, 1, 2. And they want to know, I think there's a probability of 0.6. But we want you to tell me what is this z-score. We don't know the z-score to go with 0.6 probability. Well, see, this is where they give you the 4 digits. They're giving us 4 digits, 0.600. That means they're giving us an area. So you have to go to your handy dandy table and ask 2 questions. 1, is this a positive z-score or a negative z-score? It's positive because this is 0. 0, everything to the right is positive. So you know 0.6, this is 0.5, is half right here, half right here. So this is 0.6, so you know it's going to be a positive z-score. And you look for 0.6 in the handy-dandy table. 0.6, find the closest number to 0.6. Now what I tell students, and I'm going to blow this up, I don't like to, but I'm going to blow it up. Think of 6 as $6. Everybody can do money a whole lot quicker in their head. Okay, well there's 0.9, that ain't going to work, so let's go up. Okay, here's some 0.7s. Oh, there's some 0.6s right there. Let's find $6. Okay, there's the closest two right here. $5.98, $6.02. Which one's closest? Well, actually, it's $5.99 and $6.03. Which one's closer? Well, Hubert, $5.99 closer. All right, then that's your answer. So $5.98. Can't. There we go. Put my finger there. 5.5987 is your answer. So you've got the probability of 0.5987, which corresponds to 0.05, and I've got to move it over slowly. 0.25. 0.2 in that direction and 0.5 in this direction. So your z-score is right here, 0.25. That's your z-score. So that's the z-score that corresponds to the closest number you can get to of 0.6 probability. How much are you off? 0.5990, I believe it came out to be. 0.59, what was it? I'm sorry. 0.5987. 0.5987 gave us 0.25. And we said this is 599 against 6. That's the closest you're going to get. So there's your z-score. Now that's 6.2, finding the z-score given an area. What about 6.3? Well, in 6.3, same thing. They're going to say, okay, we got an area, and we'll say these are IQ scores or something, and we want to know what is the probability of an area being greater than this z-score right here. And are they going to say point, I don't know, 0.75, 0, 0. And our z-scores are, I mean, our numbers are 100, 110, 120, negative 90, and negative 80. Alright, they give us this, and they give us this. And they want to know what that z-score is that corresponds to 75% greater. Okay, Hubert, 75% greater, that means 25% on the left-hand side, because the table is going to give us that. Yes, that's right, class. So we've got to find the z-score that corresponds with 0.25 area. Okay, what we got to do first, Hubert? We got to change this to a z-score, but we're not sure what 0.75 is. It may go to here, it may go a little bit over this. So you don't know that it's actually touching this. It could be touching that right there. Let's say it is. There's the, they're asking for this number right here. That's what they're asking for. Let's just forget this. Alright. Okay, we gotta go to 0.75 or 0.25. So you go to your handy dandy negative z-score, because you know this is negative. And 0.25, I'm gonna blow it up again, just so you can see it. Things I do for my students. Okay, 0.25. Where is 0.25? I don't see 0.25, Hubert. Well, we've got to look for it. So let's go down, down. Hey, there we go. 0.2. Here we go. 0.25, 0.25, 0.25. Oh, okay, back up. There we go. Look at there. Okay, I'm gonna change 0.25. I'm gonna change that to $25 or $2.50. What's closer, $2.48 or $2.51? What's closer to $2.50? That one, Hubert. That's right. And that's going to be 0.07 and negative 0.6, negative 0.67. So we know from our looking at the table, we know that this point right here is 0.67. Well, that's fine, but 0.67 doesn't tell us anything in respects to 90 and 100 and oh, that's not doesn't tell us anything. So what do you do, Hubert? Well, you're going to have to use your formula. Now, I tell students that if they want to find x is equal to Oz plus mu. That's what I tell students to do. Oz plus mu. This is your standard deviation. This is your z-score, and this is your mean. Your mean is right there, 100. Z-score is 0.67. Your standard deviation is 10. And now you just do the math. Now you don't have to use a calculator, people. Please don't tell me you put 10 times 0.67 in a calculator. I hope you do not do that. Because when you multiply by 10, you move the decimal to the right one place. So that would be 6.7 plus 10 plus 100 is equal to 106.7, and that is the x that corresponds to 75%. That doesn't look right because that's 100, so that's not right. We've got a problem. Let me make sure. Oh, that's a negative. There we go. Negative 0.67. There we go. Negative 0.67. Sorry about that. Plus 100. That's going to be 93.3. And that is the score that corresponds. That's the IQ score that corresponds to this z-score that corresponds to that probability. So that is basically, in a nutshell, 6.2 and 6.3. Introduction to 6.1 and 6.2 and 6.3. Hope that helps.